So welcome back to the community theater. We have two talks left. The first is Rachid. He will talk about Docker to the rescue of ops teams and tell us about his experiences and his what he did with the monitoring system. So take it away, Rachid.
Yep. Can you hear me? Yeah. So hello everyone. Good afternoon. My name is Rachid Zarouali. I'm the CIO of Synolia. Basically, we do a lot of Docker stuff. Actually, internally, we had some projects, and the one that I'm talking about is how Docker saved one of the main projects that we had a few years ago. We did some things, and I'll tell you about it later. So the agenda would be, we'll talk about a little bit of monitoring, but very little bit. We'll talk about security. We'll talk about private registry and how we use it, actually. We'll talk about CI/CD, but most of all, we'll talk about Docker experience. The experience that we made using Docker and how Docker itself helped us solving most of our problems. As always, I always like to tell a story, and this one is a story as well. And it's a story that we start in June 2014. We wanted to rebuild a whole monitoring system from scratch. We had something that was kind of monolithic, and we couldn't simply update it. So we decided to drop everything and to rebuild from scratch. We had the idea to build something that would be microservices oriented, so that every blocks of the system would do one thing and would do it greatly. And we wanted to be modular. What we wanted to have is that we wanted to be able to switch any blocks whatever we want. If we want, for example, to switch the collectors from a version to another, from a solution to another, we didn't want to have to rebuild everything. But we made it some rule first. We wanted to have something that it's simple. We didn't want to have, for example, a solution with 4 languages, 4 different languages, with different databases, different web servers, and so on and so forth. We really wanted to have something that it would be simple, that make the things very efficiently. We wanted to put in a lot of energy in having something that uses less resources as possible. So we worked a lot on this. And we wanted to have something that could be extendable. What I mean by that is that we wanted to be able to add our own plugins, for example. We wanted to be able to develop our own plugin for a specific need. And as we had Python skills in my team, we decided to choose some of the best Python tools that we had. So basically, we did a lot of research, and we selected a few that you have here. Perhaps most of you knows of them. The idea behind this is that we needed to have collectors on each of our servers. Each collectors will set a lot of metrics, around 100 to 500 metrics per server, and then push them into a proxy each minute. So we would have something like, as far as I remember, something like a 360,000 metrics by hours that will be pushed into our old systems. We wanted to have something modular, so we split every function of the system in a very specific module. So we have collectors that you have here. We have a proxy that will collect everything and then drop every metrics into databases, and we split the alerting system and the dashboards. We wanted to have something that could be efficient in sending SMSs or emails or I don't know, notification through Twilio or something like that. And we wanted to have a tool that it's made to draw graphs and to do it efficiently. But actually, things haven't worked the way we wanted, because at first, when we tried on this project and when we selected all the models, we were about, okay, so all these models are somehow Python-based. Most of them are Python-based, so there's no real issue on building the system and on using every model. The truth is, we had a few issues. The first one would be we had to deal with different Python versions. We had to deal with Python.6, Python.7. We have to add on the same system a different version of the same libraries as well. We had some issues with Whisper, which is the backend of the system, which wasn't really made to hold the lot of metrics that we tried to push on the system at the same time. And that's exactly where we faced a great problem, because we were at a time where we selected the models, and each models were working perfectly when we pushed them on virtual machines. But virtual machines for us had a cost at that time, and we wouldn't want it to have something like 6 to 20 virtual machines to just hold the system. What we wanted to have is that we wanted to have only one host that will host every module on itself. And that's exactly what that's at that time when we thought about, okay, what do we do? What can we do to fix the idea? And I went to my team at that time, and I went about using Docker, and I was like, okay guys, I've heard about Docker, this is a great product, they do great things, we can build systems that has been portable, that are efficient, and we can move efficiently. And we were like, should we go, or should we stop there? And I was pushing on this because at that time, in June 2014, I had some hints, if I may say that, Docker could be the solution. Actually, if I may say like that, actually for us using Docker was way too soon. We didn't have enough skills. We have used Docker to test solutions like building WordPress or having Apache, but we never wrote our own Docker files. And so we were like, okay, you want us to use Docker, we don't know what Docker is, and we don't know how Docker works. So we did a gamble, and we did some tests. We wrote our own Docker files, we built a system, we spawned a very simple proof of concept platform, and we started working on this. The first Docker file that we wrote were something like this, if you saw them efficiently, and I don't know if some of you see the issues that you have here, but perhaps some of you would be like this guy on the screen and say, what's going on? Because that's exactly, what you should think at the time. Why is that? Because at first we thought containers as a whole system. So we put simply everything. We put everything on the system, and we had something like, as far as I remember, 114 layers or something like that. We had huge images. Each images of the system would be something like 1 gigabyte. And it was nearly impossible to use the system, but it was our first try, so we did the gamble and we said, okay, so let's go on. And that's exactly what happened when we started to push the system. Everything just blew up. We were like, okay guys, so yeah, we built Docker images, it's cool, we did it and it works. And we were like, okay now, spawn the proof of concept. All right, so the proof of concept blew, and we had to rework everything. When I say everything, we had to restart from learning how Docker works, how to write Docker files, and how to do the things the right way. So what we did is learning about best practices. How we should exactly wrote a good Docker file. What exactly is a Docker file? What exactly is Docker? Docker is not an operating system. We did this mistake, and it's definitely something that I would advise you not to do. Never. Never, never, never. We start by thinking about, okay, now we know how to write Docker files, but if we have to build on the local system each time every image and then put them online, then we possibly can't do it. And we start by thinking about having a very simple CI/CD system. The idea was pushing Docker files on the Git repository and having an automatic system that will build the images and push them on a private registry. And somehow we ended by having something like this. It might be perhaps very simple, but just by applying best practices, we had from 100 and around 40 layers, we came to less than 20 layers. We came from having images that would be at first 1 gigabyte to having images that have something like 340 megabytes as far as I remember. So actually we did great things and it worked pretty exactly the way we wanted. And we were like, yeah, we did it and it works. Basically, it works. It works at first and we were at the first step and we learned exactly how to build the right images. So we pushed a step further on and we said, okay, now we have to know, we know, how to build images. Now, how can we automate the images themselves? And we thought about having a very simple CI/CD system. What we only do is that we push into a Git repository and we have a system that uses, which is Drone actually. For those who don't know what Drone is a CI/CD platform entirely built on top of Docker. This is, in my personal point of view, the most efficient platform I've ever seen. To have a quick comparison, if you use tools like GitLab or Jenkins, you have something that will eat around 300 to 700 megabytes on your system. Drone uses only at first around 80 megabytes. And it does, in a very simple CI/CD system, quite the same. So what we did is that we designed the system, we used a tool named Adolint. Adolint is a Dockerfile linter. The idea behind is to have a tool that also helps us to fix the Docker files that we were written. To know that, okay, we are following the best practices the right way, we're doing the things the right way we should do them, so on and so forth. And by that time, if every test that we put on would be great, then, all right, let's push them on a registry. At this time, we built our first private registry. And that's another project that I'll be happy to share later on, but that's another challenge that we have. At the time, we had the private registry, it works, and it was like, okay, now we have the system. So we learn how to write Docker files, we learn how to use them and how to push them, and then we push a little on. To give you just a little insight of how the CI/CD works, it's very simple actually. Oops. Yeah. That's a YAML file, very simple thing, in which at the first step what we did is create our own images in which we push every tool that we needed to build all the, all the tests that we needed. Everything was in it. The second step was build, test, and push. If nothing's wrong, push it to the private registry. If there's anything wrong on it, then drop a notification. At this time, we were using HipChat. Just for a quick information, we are now using Slack. But that's exactly the same. And we're moving on. We have more things to do and a lot of things to fix. The first is that we had UDP issues. UDP issues is a very, very, very old issue that was opened on October 2013, as far as I remember, on the Docker project, which has been fixed on March this year. The problem was, if you're using IPv4, the forwarded protocol uses would be forwarded on IPv6. As we wanted everything in a container, the container that will have the ability to collect every metrics would only listen on IPv6 when we wanted to listen on IPv4. We played perhaps too much using iptables. We wanted to do some things very tricky, like some pre-forwarding, fast forwarding onto the kernel and so on and so forth. So we rewrote them later on. We had two issues actually that were pretty challenging. The first one is that at the time of the project, we had unstable data volume using Docker Engine. This, again, is a very, very old issue that has been fixed a long time ago. But as we're talking about a project that has been started on June 2014, at that time we had that issue. And what we did, and I haven't talked about too much, is that in our project we did something wrong as well. We pushed every configuration files into the images. Which means that every time that we needed to update the configuration, we have to rebuild everything. So, round 2, go on. Fix the UDP issue. We put it, the collector, we put it on the host itself. No more Docker images for the collect proxy. That is something that we will try to fix at a later date, but at that time we switched from Docker images to an application that has been pushed on the host itself. So we had to change our view on the project itself. We removed most of the iptables rules that we pushed because it was way too complicated. We're trying to do something like, I can't remember, but if I can't remember that it was really way too complicated. And what we did to fix the problem with the data volume is that we mounted directories directly on the container, which is great because we could use resources on the host. But the problem at that time is that if we wanted to have something that could be used on cluster system, then we couldn't have the matrix on every host. Matrix has been stored on the system itself, so we were stick to the host itself. And we worked again. We learned a lot of things. We had learned how Docker works. We learned how to write Docker files. We fixed many issues, and we thought, and we were great actually at this time, that there were many things to go on. But we fixed most of the issues. No dependency issues, and right now we have replaceable parts. We had movable parts, which means that if we wanted at a later time to split all the system and have, for example, the collector on a system, the database on the other, the dashboard on another machine, we had built everything. What we needed at that time is a clustering system, which has been built on Docker on the Docker engine later on. What we did as well is that we improved by simplifying the images, by reducing the images themselves, we improved the security. As perhaps you always heard these 2 days, the lighter your images is, the smaller the surface of attack you have. And we did it great actually. As I said, we learned many things, not to use IPv4. We pushed it out configuration files outside the images themselves. We somehow put them on the host and use this Ansible, for example, to push most of them. For some reasons, we didn't want to use, at that time, environment variables for MySQL password, for example. Every sensitive data, we wouldn't want to use environment variables because we found that these variables could be found whether you have access to the machine. And so what's next? Docker at that time helped us to fix our project and also opened our eyes on many great things that we could do later on. We could reduce, again, the images. We definitely know that we could do it. And one of my team is actually working on this specific aspect. The idea, again, is to have the smaller images possible so that they can be easily maintained, so that they can be easily deployed, and so that they could be also more secured. We're working on signing the images using Notary. I would be glad to share a bit of our R&D on this if you like. But we're working on this. We're working on signing every images that we produce so that we are now sure that the images that has been pushed on our system are our own. And the images that have been pushed are secured. We're working on vulnerability scanner tools that we have in DTR, for example, and there are other tools in the open source community that exist as well, who does, I would say, quite the same, but not exactly the same. And the last thing that we're trying to do, which is probably right now the hardest thing, is implementing rolling upgrades. What we wanted is that every time that an image has been tested technically and functionally, then this image will be pushed live on the system, and then the whole system will load the images. And every module on the system will reconnect to this image. But there's more. We work on this, and we migrated every of our developer on Docker. We use what we learn by working on Docker to migrate every development system on Docker. We're working on swarm clustering.
Your time is basically almost up.
Yeah, I know. We work on swarm clustering, and we are also trying on having all our production system on Docker. So what I'm trying to say is that at first when we started to use Docker, we were like, okay, should we not? We decided to go on, and we had, as I talked about, many issues, and we faced pretty challenging problems. But at that time, Docker helped us in this project. This project is live, it's completely Docker-based, and it opened up our system on other things. I think I'm on it. I'm not too late. If you have any questions, I would be happy to answer them on the hallway track, if you would join me there. Thanks again, DockerCon, for giving me the opportunity to be here to share all this knowledge that we learned. And if you want to share this talk, then please go on.